All right, let's go ahead and get started. Today we are going to do the last lesson of Module 1. So this is going to be Module 1, Lesson 4, and we actually have two sections from the book, which is 2.4 and then 2.5. So we are continuing on and we are building on what we have already learned from the previous lesson. So I'm going to do a little review. Remember, anytime you see the upside down U, it is for intersection, and that is going to be the elements common to both sets. So if we were to draw that on the Venn diagram, it would be where those two circles intersect. The U represents union, and that is going to be the all elements listed from both sets. So the union can be represented with the word or, because if that element is in A or B, it is in the union. And then intersection is represented with the word and, because that element has to be in A and B. And if we were to represent that with the Venn diagram, it would be everything inside both of those circles. And then anytime we have that tick mark or the apostrophe, so A with an apostrophe is going to be the complement of A, which is what is not in set A, but is in the universal set. Okay, so this is just a review of the things that we talked about from lesson 3. We are going to continue to build on those. We're going to start getting into 3 sets and multiple different operations in one problem. So exercise 1 says to use the Venn diagram to represent each set in roster form. And then they give us the Venn diagram with 3 sets, A, B, and C. And then our universal set is everything inside of the box. So they want us to list these sets in roster form. So we're starting with the set A. Set A is going to be everything that is inside of the circle A. And remember, Pearson, they want you to list the elements in ascending order. So it would be in order 1, 2, 3, 4, 5, 6, 7, and 8. For B, we want the union of A and B. I'm going to try to represent these with different colors. So the union of A and B, remember union, we are listing all elements from both. So it's going to be everything inside of both of these circles. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 1, 2, 3, all the way to 11. C is the intersection of A and C. Intersection is where those two circles intersect. So A and C, they intersect in this football right here. And we have the numbers 6, 7, and 8. D is the intersection of A, B, and C. So we want to look where all 3 of the circles intersect, and that is going to be this middle piece, this middle little triangle, and the only element in there is 6. And then our last one on this exercise is E, and we want the union of all 3 So the union would be everything inside of all three of these circles, which is all of the numbers 1 through 12. 1, 2, 3, all the way to 12. All right, number 2, find each of the following sets. So we have lots of different operations in this problem. And one thing that you need to know is that you are always going to start inside your parentheses first, because your order of operations, please excuse my dear Aunt Sally, P is first, which is your parentheses. So we are going to start inside of our parentheses. They tell us that the universal set are the numbers 1 through 7. So we are only looking at these numbers for this specific problem. And then they give us the sets for W, X, and Y. So on the parentheses, we want the intersection of X and Y. So we want the elements that are common to both of those sets. So X has 1, 2, 3, and then Y has 2, 3, 4, 5, and 6. So they both have 2 and 3. So that would be the set that is inside the parentheses. And we want to union this new set with W. W has 1, 3, 5, and 7, and we are going to throw these numbers into that set. So 1, we're going to throw the 2 in. We already have 3, and then 5, 7. This would be our answer for 4A. Okay. B, we have some complements that we need to address first. So we are starting inside of the parentheses with the union of X and the complement of Y. So let's go ahead and write those up here. We want to do the complement of Y and then the complement of W. So remember, our complement is what is not in that set, but what is left in the universal set. So the easiest way, if you are a visual person, you can mark through these numbers. So whatever is in our set W has 1, 3, 5, 7. I'm going to cross those off, and we are left with 2, 4, and 6 in our complement. And we can do the same thing for Y. Y has 2, 3, 4, 5, and 6. And we are left with 1 and 7. So now we can start to perform our operations. So we have the union of X and the complement of Y. X has 1, 2, and 3. And then the complement of Y has 1 and 7. We already have 1 in there, but we can add 7 in. And then we are going to intersect that with the complement of W. So, oops. So the complement of W is 2, 4, and 6. And we want to intersect that with our new set 1, 2, 3, 7. Our intersection is the elements common to both sets. So in this case, we have 2 that is in both of these sets. So that is going to be the only number in our final answer. Let me box these in. Okay. On C, so same thing, we're starting inside of our parentheses. We are taking the union of W and X. Now, we do have a tick mark, but it is outside of our parentheses. So we're going to work inside of our parentheses first, and then we'll take that complement. So W and X, whenever we union those together, W has 1, 3, 5, 7. X has 1, 2, and 3. So we're going to join those together. 1, 2, 3, 5, and 7. And we want to find the complement of that. So the complement of that, we would go to our universal set and find the numbers that are left after we cross these out. So we have 1, 2, 3, 5, and 7. We are left with 4 and 6. And we still have one more operation that we need to do. We need to intersect this set with our set Y. Y has 2, 3, 4, 5, and 6. So our intersection is going to be the elements common to both. So it looks like they both have 4 and 6. So that is going to be our answer. Okay. D, all right, we have 2 parentheses. So we need to work inside of this one and in this one, and we will union those 2 sets together. So the first one is the intersection of W and X. So the elements that are common to W and X. So W has 1, 3, 5, 7. X has 1, 2, 3. So it looks like our union is going to be 1 and 3. Okay. And then we're going to do this other parentheses. We want the intersection of W and Y. So W has 1, 3, 5, 7, and Y has 2, 3, 4, 5, and 6. So the elements that are in both of these sets looks like they both have 3 and they both have 5. And we want the union of these 2 sets. So we are left with 1, 3, and 5. Remember, we are not going to put repeated elements in there twice. All right, our last one, we are taking the union of those 3 sets, and then we're finding the complement. So let's take the union of those first, and then we'll find that complement. So W has 1, 3, 5, 7. X has 1, 2, 3. And then Y has 2, 3, 4, 5, and 6. So it looks like we have all of the numbers. We have 1, we have 2, we have 3, 4, 5, 6, and 7. So that union is going to be all the numbers 1, 2, 3, 4, 5, 6, 7. So that looks like it is all of our numbers in that universal set. So if we were to mark out each of these numbers, we would have nothing left. So the complement of this set is just our empty set. So you can represent it with the brackets or you can use the null symbol. Okay. Number 3, use the Venn diagram to determine whether the given sets are equal for sets A and B. So in this particular problem, they are using these as the elements. So the Roman numerals are the actual elements in each piece. So they're giving us 2 different sets that they want us to perform these operations, and we want to see if it's the same set. So the first one, we have the union of A and B, and then we'll find the complement. So let's find that union first. The union of A and B, we would have Roman numeral 1, 2, and 3. And if we take the complement of that, it would be whatever it is not in that set. So the only thing that would be left would be our Roman numeral 4. And we want to compare that set with the second set, the intersection of A and B, and the complement of that. So let's start in our parentheses. We're going to do the intersection first. The intersection is going to be that middle piece right here, which is Roman numeral 2. Okay, and now we want to find the complement of that. So everything that's not Roman numeral 2 would be 1, 3, and 4. So 1, 3, and 4. So we are comparing this set with this one, and they do not have the same elements. So these are not equal. Okay. On B, we have a little bit more that we are doing. So the first set that we're looking at, we take the complement of A and we're intersecting that with B. And then we want the complement of that. Okay, so let's start in our parentheses. The intersection of the complement of A and B. So I'm going to write that out. The complement of A. So what is not in A? We have 3 and 4. So Roman numeral 3, Roman numeral 4. And we want to intersect that with B, which has 2 and 3. Okay. When we intersect, we are finding the elements common to both. Looks like 3 is going to be the only element that's in both of those. Okay. So that is what is inside of our parentheses. We still have to find the complement of that. When we find the complement, we're going to take everything except that 3, which is 1, 2, and 4. So 1, 2, and 4. So this was the first set that we are looking at. Over here, let me highlight. And now we can do the second, which is the union of A and the complement of B. So that complement of B, what is not in B, is 1 and 4. And we are going to union that with A, which is 1 and 2. And when we union, we join everything together. So we get 1, 2, and 4. So we are comparing that to our first set. And it looks like these two are equal. All right, number 4. Use the Venn diagram to indicate in which region 1 through 8 each television show should be placed. So they have some television shows. We have A, B, C, and D. So we have The Blacklist, Big Bang Theory, Empire, and then 2.5 Men. So the blacklist. Let's look at our table, and we want to find where the blacklist is. So we'll do yellow for the blacklist. And I see the blacklist on 2013, 2014, but I don't see it anywhere else. So it shows the blacklist on 2013, 2014, but that's it. So it looks like it's going to go into region 1 because it cannot go into any other circles. So region 1 is only that first set. So the blacklist is going into region 1. So now on these problems, they are using the Roman numerals to actually label each piece of our Venn diagram. So each different piece has a different label. Okay. The Big Bang Theory. We'll do pink for the Big Bang Theory. So let's look at our table. We have the Big Bang Theory in 2013, 2014, and then 2014, 2015, and then also 2015, 2016. So where the Big Bang Theory is in all three of these circles. So where those circles intersect is in region 5. Okay. Empire. Let's look at our table, and we see that Empire is on 2014 and 15, and then 15 and 16. So this is on this second circle and then our bottom circle. So where those two intersect, they intersect in this entire football, but this middle piece has that first set included, and we only want the last two sets. So it would be in region 6. And then our last one is 2.5 Men. We'll do red. So 2.5 Men. I do not see that on here at all, so it's going to have to go outside of those circles in region 8. All right, number 5. Let our universal set be the set of countries or regions shown in the chart. So we're looking at these specific countries right here. A is going to be the set of countries with the male life expectancy that exceeds 75 years. B is going to be the female expectancy that exceeds 80 years. And C is the countries with fewer than 400 persons per doctor. So the first thing that I want to do is just mark through and label our table. So it says that A is going to be where the male life expectancy exceeds 75 years. So let's look at our countries, and anything that's over 75, we're going to put in that set A. So the US, Italy, Russia does not exceed 75, East Africa does not exceed 75, Japan, and England exceeds 75. So we know that these 4 countries can go in our set A. Let's look at set B. Set B is where the female expectancy is over 80 years. So if it's over 80 years, they're going to go in set B. So the US, Italy, no Russia, no East Africa, Japan, England, no Iran. Okay, and then C is going to be where there are fewer than 400 persons per doctor. So the US is less than 400, Italy is less than 400, Russia is less than 400, East Africa Japan, England, and Iran are not less than 400, so they cannot go in C. So now that we have looked at that, we can label our Venn diagram and we can put each country where it goes. So let's start with the US. The US, they meet all three of those requirements, so they are going to go in our middle piece. Same thing for Italy. Russia only meets the criteria for C, so they are going to go down here. East Africa does not meet any of those, neither does Iran. So we have East Africa and Iran are both outside of those circles. Japan meets the criteria for A and B, but not C, so it cannot be in circle C. Same thing for England. So Japan and England go in this region, and that is everybody. And that's the last exercise for 2.4. Let's go over to 2.5. This is the end of Module 1, Lesson 4. So Module 1, Lesson 4. All right, so we are going to use the Venn diagram to answer the following questions. Now, anytime you see these Roman numerals, that is the region, and these numbers are going to be the cardinal number for that region. So whenever you do your homework, it's going to give you directions, and it'll tell you that the numbers represent the cardinal number for that region. So just read the directions whenever you do these problems. So A says, how many elements belong to set B? So B has two regions. We have this football region and then this other region. So region 2 and region 3. And we have 9 plus 11. So we have 20. Oops. It's getting ahead of myself. So 9 plus 11 gives us 20 elements. How many elements belong to set A but not set B? So anytime it says not, we cannot do anything that is in that set. So the only region that we can look at is region 1, which would be 17 elements. C, how many elements belong to set A or C? Anytime that you see or, we are looking for the union. So we are going to add 17 plus 9 plus 11, which gives us 37 elements. D, how many elements belong to neither set A or set B? So we don't want anything in A or B. We're left with 7 elements outside of those sets. And then the last one is, how many elements are there in the universal set? The universal set is everything in our box. So we're going to add 17 plus 9 plus 11 plus 7, which gives us 44 total elements. Number 2, we're going to use our Venn diagram to answer the following questions. And letter A says, how many elements belong to set A or B? So kind of similar to what we're doing in number 1, but now we have 3 different sets. So set A or set B is going to be the union of A and B. So we have 5 plus 1 plus 2 plus 7 plus 6 plus 3. So A or B is everything that is inside of both of these sets. That's kind of sloppy, but all of these numbers, which gives us 24 elements. B, how many elements belong to set A or C, but not B? So remember, whenever it says not, we cannot use anything inside of that set. So not B, but we want A or C. So we are left with 5 plus 2 plus 10, 17 elements. And then the last one, considering sets A, B, and C, how many elements belong to at least 2 of these sets? So at least 2. So that means that we want to look where there are 2 or more sets. So what that means is we want to look in these intersection pieces because that is where these 2 sets intersect. So the elements inside of these pieces are in 2 or more sets. Because the elements over here by themselves, they are only in A. So they're only in one set. So we want to look where they intersect. So 1, 2, 7, and 3. 7 plus 3 gives us 13 elements. All right, last exercise.
Idea. Once I heard a Muslim
Oh
story,
gosh.
or once I heard that that came from a Muslim, right? It's
All right, it is 2 o'clock, so I will be recording this because some people have meetings and things going on today. So I will ask that everybody mute themselves, and then if you have
All right, number 3. All right, number 3, use the Venn diagram in the given conditions to determine the number of elements in each region or explain why the conditions are impossible to meet. So they give us all of these conditions. They tell us that the number of elements in our universal set is 38. We have the number of elements in A, B, and C, and then we have the number of elements where those sets intersect. So the Roman numerals represent those different regions, and we want to find the number of elements in each region. So the trick to this one is to start at the very end. So start here. And then we're going to work backwards. So the number of elements in our intersection of A, B, and C is going to be this piece right here. And I'm going to try and color code each different piece. So there are 7 elements that go in our middle piece. So nothing crazy there. We're just putting that information in. After this, we are going to start getting into some more work. So the intersection of B and C. So that is going to be where those 2 circles intersect. And it is this football piece right here. So if you look, there are 2 different regions. We have region 5 and region 6. And we need both of those regions to total to 8 elements. We already have 7 in the middle, so we just need 1 more element to total to 8. Okay. The intersection of A and C. We'll do green. There are 11 elements in that intersection. And that intersection piece is this football right here. So, same thing. We already have 7 in Region 5. This football contains 2 different regions, Region 5 and Region 4. Region 5 has 7 elements, so we need to figure out how many we need to total to 11. So we just need 4 more elements for this entire football to total to 11. Okay, we're going to keep going. Let's do this one. And the next information is the intersection of A and B, which is this football right here. This football contains 2 regions, Region 2 and Region 5. Region 5, again, has 7 pieces. We need those 2 pieces to total to 17. So 10 plus 7 gives us 17. Okay. Next one, let me do orange. Circle C has 18 elements. Set C is this entire circle. This circle has 4 different regions. We have region 4, 5, 6, and 7. We need all 4 of those regions to total to 18. So we have 4 plus 7 is 11, plus 1 is 12. We have 12 elements already in our circle, and we need to get to 18. So we need 6 more elements to get to 18. All right, set B. We have set B is this whole circle, getting kind of wonky. B is this circle. We have 4 regions. We need those 4 regions to total to 21. We have 10 plus 7 is 17, plus 1 is 18. So we need 3 more to get to 21. All right, we're almost done. Let me do purple. A has 26 elements. And our circle A is, our set A is this circle. We have regions 1, 2, 4, and 5. We need them all to total to 26. 10 plus 7 is 17, plus 4 is 21. We need 5 more elements to get to 26. And then our last piece of information is our universal set. The universal set is everything in our box. So, something that Pearson likes to do, they like to give you multiples of 10. So you can easily add these up. So they give us 10. 7 and 3 is 10, so that's 20. 4 and 6 is 10, so that's 30. Then we have 5, 35, and 1 is 36. We need 38 total elements, so we only need 2 more elements outside of our circles for our universal set. So whenever you fill out these answers in Pearson, it's going to say like region 1, and then it'll have a box. Region 2, and give you a box. Region 3, region 4, region 5, region 6, region 7, and then region 8. And then you are going to put all of your answers in from your circle into these boxes. So we have 5 elements in region 1. We have 10 in region 2. We have 3 elements in region 3. We have 4 in region 4. 7 in region 5. 1 in region 6. 6 in region 7, and then we have 2 in region 8. So this is how you will answer those questions. All right. Letter B. I'm not going to do this one because you're going to work this the exact same way as you would this question, but you're going to find out that it doesn't work out. And whenever you do these type of questions, it'll have a multiple choice where you can either put the answers in, or you're going to say that this does not work out because, for instance, let me start drawing it and you'll see why it doesn't work out. So we start here, our intersection of all three, we have 2 elements. Okay. Our intersection of B and C is 7. So we would need 5 to total those to 7. I'm sorry, let me label ABC. Our intersection of A and C is 9. So this piece right here. So we need 7 plus 2 to get to 9. And then let's look at set C. So set C, it says we have 12 pieces. But if you look, we already have 12 plus 2. So we already have 14 pieces, 14 elements in set C. So it does not work out. Does not work out. We already have 14 elements in C, and C only has 12 elements. So it's going to be like a multiple choice question, and you select that and you'll have to fill in like how many elements we already have and whatnot. So that's how that problem is. And that is all for lesson 4.